This standard is focusing on another set of algebra functions where they're called rational expressions, and we're not going to be solving these quite yet. We're just going to be working with simplifying them, because when you have to solve equations that involve rational expressions, simplifying always makes your job easier, just like most things. So, rational is it's not really fancy, but it's an algebra term for fractions. So when you see the word rational expression, you're talking about something that has a fraction, and not just any fraction, but a fraction that has variables in your denominators. So this standard utilizes skills that you've already mastered and been working with. Adds in one thing to the mix, which is these variables in the denominator. But you've already been working with fractions since, I think, as early as 5th grade, maybe even before that. So we're going to look at two situations here. If I had 2/3 plus 4/5, and I told you to add those together, can someone tell me what I would have to do? Michaela. No, it's fine. I know what you meant. So we need to get the numbers at the bottom the same. If they're not the same, they're like not like terms, so you can't combine them. Yeah. So the least common denominator, as Michaela said, was or is 15 in this case. So we'd have to multiply this by 5/5, and this one by 3/3. And so then you'd get 10/15. Now, is 10/15 technically still 2/3? Yeah. So you're not changing, when you're getting common denominators, you're not changing the value of the expression. It's still 2/3. You're just changing the way that it looks so that you can manipulate the equation. So in this case, we have 12/15. Now that I have common denominators, it's going to become 22/30, right? 22/15. Yep. Make sure that when you add fractions, you're only adding across the top. Some of you looked at me like I was crazy. I do know what I'm talking about most of the time. All right, so 22/15 would be your answer here. Now, if instead of adding, we multiply, how does that change my problem? Evan?
You cross multiply.
Not quite. Yeah. Yeah. So in this case, when you're multiplying fractions, there's no equal sign involved or anything. You're just multiplying fractions. We always multiply across on the top and the bottom. So we get 8/15 here. Okay. A common mistake, and I'm not going to write it down because I don't want this in your notes, but a common mistake is that when you're multiplying fractions, people try to, like I said, cross multiply. And I think what you meant was cross like this way across. But some people cross this way, like and multiply the 2 and the 5 and the 4 and the 3. You cannot do that when you're just multiplying expressions. You can only do that if it's proportion. So if there's an equal sign instead of a multiplication sign, that's when you do the cross multiplication. Okay, but we're not working with solving, so we're not going to have any equal signs in this standard. We're just working with simplifying. So we'll be adding and subtracting and multiplying and eventually dividing. All right, so to fill in some of these blanks, whenever you have fractions that you are adding or subtracting, as a couple of you said already, you must have what? Common denominators. Okay, so my question I pose is, so when fractions have algebraic expressions, meaning x's, variables, in the denominator instead of just numbers, what changes? Do I still need common denominators to add and subtract? Yes. Okay. So there's a few other things we have to do, but essentially we're doing the same thing. You're still getting common denominators before you add and subtract, even though there's variables now. All right, so we still need common denominators, but now those denominators will be variables or algebraic expressions, which that just means it's going to be not just maybe x, but maybe x plus 3 or something like that. Some expression that has an x in it. Alright, so when you multiply fractions, we're going to multiply across the top and the bottom. And when you add or subtract, because subtraction is really just adding a negative. So when you add or subtract fractions, you add across the top after getting common denominators. So we're going to work with adding and subtracting first, kind of hammer that really good today, because the multiplying part is actually a little simpler than adding and subtracting. So I want to get a good practice in here with adding and subtracting. Alright, when you have variables in your fractions that you're trying to simplify, the first key step that you have to do when you're adding and subtracting is factor the denominators. Now when we get to multiplying, we factor everything. We factor the numerators and the denominators, but with adding and subtracting, we just really care about getting the denominators the same, so we just factor the denominators. Okay. Second step, if you don't do the first step, the second step is going to be very difficult. So, doing the first step really simplifies things for you, makes it easier. Alright, second step is to obtain your common denominators. And then before you add or subtract across the numerators, across the top, you're going to need to simplify. And you could simplify the numerators and denominators, but really I just care, and I mean, you're like the answer key to a book or something would just care that you simplify the numerators. Because if you don't simplify the numerators, a lot of times you can't add your like terms. So we simplify the numerators, and then we add or subtract across the top. Okay. When you're ready, go ahead and flip the page. Alright, so for example 1, we're going to start with 2x minus 1 over x squared minus x minus 2 minus fraction 1 over x minus 2. So you can see there's fractions, but in both cases we have variables in the numerator and the denominator. Alright. First thing we're going to do is factor the denominators. Okay, so let's start with this one. This is a quadratic, so I can definitely factor it. And almost always, since you're just being introduced to this now, like in Algebra 3, if you take that, you go a little bit deeper into like different denominators, but the ones I'm going to give you are pretty much going to look like this, where you're not going to have an a value other than 1, so you're not going to have to do any like crazy long factoring on this side. You can just guess and check and have it go a little quicker. So we'd have x and x. I'm factoring this, if I lost you at some point. And then, what are two numbers that multiply to get negative 2 and add to get negative 1?
Negative 2 and 1.
Negative 2 and 1. So we're going to include that. Positive 1. Okay, and then we factor this denominator over here. Now, does x minus 2 factor?
No.
No. So, if it does not factor, then we have to glue my pieces together, because essentially this is a factor then. We can't separate them. They're a unit. So this x minus 2 is a factor. We're going to group them together with parentheses and treat it as a unit. So when you look at your denominators, to get them common, that means they have to have the exact same expressions in both denominators. They already have one expression in common. What's the one expression they have in common? X minus 2. But the one we don't have in both is the x plus 1. Yep. So we can do the same thing we do with numbers. Now we're just doing it with algebraic expressions. So to get this x plus 1 in this fraction, so I have the same thing on the bottoms of my fractions. I'm going to multiply by the fancy form of 1, x plus 1 over x plus 1. Now, first fraction didn't change at all. Notice I'm not refoiling stuff back together, because when you get common denominators, I don't care that you simplify the denominators. You can just leave them as is. Now, over here, we have this 1 times x plus 1. Whoops. Over now the same denominator. Because you're just, when you're multiplying fractions, remember you multiply across on the top and the bottom. Now to simplify this, does it really matter that I have the 1 times x plus 1? No. It's going to be the same as just saying x plus 1, right? Yes or no? Yeah. So if you wanted to simplify that, like if this was a 2, then we'd have to distribute the 2 through. But since it's a 1, I'm just going to write it as x plus 1. Now the reason I drop the parentheses at this point is because now it's more clear what's my like terms as I'm moving left to right. Because now that I have common denominators, I can subtract across the top. So we have 2x, and what am I subtracting from 2x on the top? An x, so I get just x, right? And then negative 1, what am I subtracting from the negative 1? 1. So negative 1 minus 1 gives me negative 2. Now, if this happens where you have the same exact expression on the top as one of your expressions on the bottom, what can you do there? Do you think? You can cancel. It'd be like if you had just a 3 on the top and a 3 on the bottom. The 3's would cancel. Excuse me. So since this is exactly since this is exactly the same as this expression on the bottom, we can simplify one more step. Those cancel, and you end up getting just 1 over x plus 1. That won't happen all the time, but sometimes when you simplify, one last thing cancels at the end. So this would be the answer probably in the back of the book that you would have. All right, let's do another one. Yeah, let's do this one. 5 over 3x minus 12 plus 3x plus 1 over x squared minus x minus 12 minus 2/3. Now, I'm giving you, this one's probably more difficult than I would give you on a test. But I figure if we do the difficult ones here and we can handle them here, then you'll be completely fine with it. Okay. First thing that we're going to do is in each denominator we're going to go through and factor. Now that includes just pulling out greatest common factors, because when you look at the first one, it's not a quadratic, so you might think, oh, I can't factor that, but you can at least pull out a what? 3. So we want to at least pull out the greatest common factor if possible. Okay, so we're factoring all the denominators. This next one, when I factor, what are the two numbers that multiply to get negative 12 and add to get negative 1? Which one's negative? Negative 4, positive 3. And then that last fraction is just a number at this point. So, okay. So we're going to look piece by piece. Now I see 3 different units here. Like when you just look at everything, I see a 3 that's in some denominators. I see an x minus 4, and then I also see a what? X plus 3. Now your common denominator has to have all 3 pieces in all 3 fractions. Okay? So in the first fraction, what unit or what piece of the denominator is missing? X plus 3 is missing from this one, right? So we have to multiply this one by x plus 3 over x plus 3. Okay. What about this one? The 3. Okay, so we're going to multiply this fraction by just 3 over 3, which is kind of nice. And then what about that last fraction? it's missing two pieces, the x minus 4 and the x plus 3. So that one's going to get multiplied by two things. Okay. So we're going to just deal with one at a time. Once you figure out what piece needs to be included with every fraction, we're going to simplify each one at a time. Don't worry about simplifying the bottoms. We're just going to worry about simplifying the top. So what do I do to simplify this 5 and this x plus 3 when I multiply them together? What do I do with 5? Distribute. So we get 5x plus 15. Some of you said. Over that denominator. Okay. Same kind of thing here with this fraction. I'm going to have to take this 3 on the top and distribute it through to the 3x and to the 1. Even though there's not parentheses here, you can imagine them being there because the 3 has to multiply with both. So we'd have 9x plus 3. And the denominator is the same. Okay. What about this last fraction here? What am I going to have to do to simplify the top? Distribute, but I have two binomials here. So what do I usually do to simplify that? Foil. Okay. So I'm going to kind of foil above and then distribute the 2 through before I write it down here. So when I foil this together, x times x gives me x squared. Outer gives me 3x. Inner gives me negative 4x. So that would give me negative x minus 12. And then distribute the 2 through. Over the same bottom. Okay. Now we're almost done. Because now that we've simplified all the top, we just have to basically add and subtract like terms on the top. Okay. So starting with the 5x. I'm going to take 5x, I'm going to add 9x, so what's 5x plus 9x? 14x, and then I have to subtract what? Negative 2x, right? So if I'm subtracting a negative 2x, really what am I doing there? Adding. Okay, so 5x plus 9x is 14x, minus negative 2 gives me 16x. Good. And then the 15 plus 3 is 18, and then I'm subtracting a negative 24. So that would be adding, so plus 42. And then what's the last piece? Minus 2x squared. Good, because we're subtracting it. Okay. And then you're done. And that would be your answer at the end. Not super pretty, but you did what you're supposed to do, which is to add and subtract those three fractions together. Okay. We're going to do 2 of these on whiteboards before we go on to multiplying. So these on whiteboards, I'm going to have you get up and move around a little bit with partners, and then we'll come back together to do the multiplying.